Hello, everyone. Welcome back. We have a lesson here. It's going to be on 6.2 lesson and properties of exponents. This should be a review. This should be a review for quite a few of you, but we need to know these properties of exponents. We're going to have a quick lesson on this today. And nice job to all of you who did the worksheet from Monday. It's Wednesday, and I've got quite a few submittals, and good work on that. Hold on a second. I'm going to get this. It's a little bit better. Bright sunny day today, shining in here. Anyway, so let's get started on the lesson. And we're going to have a similar format today. Okay, so we'll do a lesson. Then we're going to check your teams for the short little worksheet, and it should be attached to the assignment, and you can work on it at your leisure today and tomorrow, and try to get it to me on Friday, and be worth 5 points. No quiz this week. Be a quiz next week sometime, but good job on the first one. Any questions, make sure that you're setting them through Teams to me. Quite a few of you have been doing that, and good job. Also, hopefully the videos worked out better. I've got a YouTube channel there set up for the videos, and the videos, I uploaded those, so hopefully they're easier to get to. The first video I had uploaded it with some protection there, and I don't know why I did that, but anyway. Anyway, just a couple other things too. Make sure that you keep doing your attendance. Okay, do your attendance for Skyward. Get that updated. But we have a 5-point assignment going in today from Monday, and then this one will be worth 5 points too for Friday. All right, so here we go. This is properties of exponents. I'm going to go at a pretty good clip here because using the properties of exponents, it should be a review for all of you. And if not, this will be should be a great video for you to kind of refer back to if you have questions. Okay, so this first key idea is our objective today is we're going to be able to solve expressions using properties of exponents. All right, so the first key idea is the product of powers property. Basically, it says when you're multiplying with powers with the same base, you add your exponents. So we have a numbers example here and an algebra example. Second one is the quotient of powers property. The quotient of powers property states that if you have, if you're dividing with the same base, you subtract their exponents. We have a numbers example here plus an algebra example. The last one is the power of power property. So if you have find a power of a power, you multiply the exponents. Here's the numbers example down here, along with an algebra example. Okay, so today's lesson encompasses, we have 1, 2, 3, 4 examples, and a few on your own, so we're going to go at a pretty good pace here, okay? All right, this first one, write your answer using only positive exponents, 3 to the second times 3 to the sixth. Okay, so you have the same base. So what you're going to be doing is adding the exponents. So the same base of 3, so you're going to add 3 to the 2 plus 6. And that's equal to 3 to the 8th. Letter B, -4 to the second divided by -4 to the 7th. So you have the same base of -4, and you are dividing in this case. So you are looking at using the quotients property. So we are going to be subtracting 2 minus 7. Okay, so in that case, you have the -4 to the 2 minus 7, which is equal to negative 4 to the negative 5. Okay, so we need to take care of that negative exponent. And we think of the reciprocal here at 1 over negative 4 raised to the 5th power. Okay, so we want to make our answers with positive exponents, and that would be letter B. Letter C is a power to a power property. Z to the 4th raised to the negative 3. And when you have a problem like this, you have a base of Z, and you end up multiplying 4 times the negative 3. So power to a power property, power of a power property, 4 times negative 3 is negative 12. Okay. All right, so with the negative 12, we have to take care of that negative exponent. And just like with letter B example, that ends up being 1 over Z to the 12th. 1 over Z to the 12th. Okay, quite a few on your owns here. I'll go at a pretty good pace here. Same base of 10. We're going to add the 2 exponents. So 10 to the 4 plus negative 6 is equal to 10 to the negative 2. And with that in mind, 10 to the negative 2 is equal to 1 over 10 to the 2nd power. Number 2, x to the 9th times x to the negative 9 is equal to x to the 9 plus negative 9, which is equal to x to the 0. X to the 0, x to the 0 property would equal 1. Number 3, negative of 5 to the 8th divided by the negative of 5 to the 4th. Okay, so what we have here is you got the 2 negatives, so they cancel each other out. So you end up with 5 to the 8 minus 4, which is equal to 5 to the 4th. Example 4, y to the 6th divided by y to the 7th is equal to y to the 6 minus 7. That's the quotient property. Y to the negative 1, and that's 1 over y to the 1. Number 5, we have a power raised to a power property. That is equal to 6 to the negative 2 times negative 5 times negative 5. And that's equal to 6 to the positive 10. Last one is power to a power property. W to the 12th, all of that's raised to the 5th. That's the power to the power property. W to the 12 times 5. And that's equal to W to the 60th. 6 good examples. Next, we're going to talk about the power of a product property and the power of a quotient property. So what this states that if you find a power product, find the power of each factor and multiply. Okay, so with this one, you've got a negative 1.5 times y, and that's raised to the 2nd. You end up with the negative 1.5 to the 2nd, negative 1.5 to the 2nd, times y to the 2nd. So each of these items inside the parentheses will have the power of a product property. And that's equal to 2.25 times y squared. Letter B, a over negative 10 all raised to the third. This is the power of a quotient property. Power of a quotient property. So basically that a is raised to the third. And the negative 10 is raised to the third. And your answer there would be negative a to the third over 1,000. Letter C, 2x divided by 3 all raised to the negative 5 property. So what this is you're going to take the 2 and the x and raise that to the negative 5. And you're going to raise the 3 to the negative 5. Your next step would include basically we're going to take care of the negative exponent by switching these two positions, the reciprocals of both. So you'd have the 3 now is on the numerator position, raised to the 5th. And the 2x is in the denominator position, raised to the 5th. Now what we have is the power of a product property. So 3 to the 5th is 243. Two to the 5th and x to the 5th. Okay, we want to simplify that 2 to the 5th is 32. So your answer is 243 divided by 32 x to the 5th. And that's letter C. All right, on your own, simplify, write your answer using only positive exponents. All right, 10y raised to the negative 3. Okay, so let's take care of the negative exponent. By the definition of a negative exponent, you have 1 over 10y to the third. Now you have a power of a product property, 10 to the third, y to the third. So you got 1 over 10 to the third, y to the third. And your answer then is 1 over 1,000 y to the third. All right, next. Negative 4 divided by n raised to the 5th. Okay, so you have a quotient and you're raising it to a power, that is negative 4 raised to the 5th over n raised to the 5th. And your answer there is negative 1,024. 1,024 over n to the 5th. All right, number 9, 1 over 2k to the second. All of that's raised to the 5th. Okay, so that's, you've got 1 to the 5th over 2k squared raised to the 5th. Okay. And what that is, you've got 1 to the 5th, which is 1. Now you've got this thing here, 2k to the second. and you're raising that to the 5th power. So that's 2 to the 5th. And then you have got k to the 2nd raised to the 5th power, and that is k to the 10th. Power to a power. So your final answer there is 1 over 32 k to the 10th. 1 over 32 k to the 10th. And the last on your own, number 10, 6c divided by 7, all of it raised to the negative 2 power. Okay, so this is like 6c to the negative 2. And this is like 7 to the negative 2, divided by 7 to the negative 2. All right, so let's take care of the negative exponents first. So this is fairly easy. You saw it in the previous examples. Basically, they kind of switch positions, all right, using the negative exponent. So the 7 now is in the numerator position, 7 squared. And the denominator is 6c, and that becomes squared, 6c squared. So your final answer there is 49, 7 squared is 49, over 36 c squared, 36 c squared. Two final examples today. Example 3. Which expression represents the volume of the cylinder? Okay, so volume of a cylinder is pi times r squared times the height. Okay, so in this case, we are just going to substitute in what we know. We know that the radius is h over 2. So we're going to take pi times r squared, the radius squared is h over 2, and we're going to square that, and we're going to take it times another h. Okay, so that's the volume of that cylinder. So then we have in our hands here is a case where we have a division, and we're raising it to the 2nd power, so we can simplify that down as h squared over 2 squared times h. So that simplifies to pi times h to the 3rd over 4. Pi times h to the 3rd divided by 4. And looking across your answers, here, I'll get my face out of the way for that one. Okay, so you've got h squared over 2, no. Pi h squared over 4, no. Pi h to the 3rd over 2, no. And your answer is D. Okay, last example, example 3. A jellyfish emits 1.25 times 10 to the 8th particles of light or photons in 6.25 times 10 to the negative 4 seconds. How many photons does the jellyfish emit each second? Write your answer in scientific notation and in standard form. Okay, so we're going to put the particles, 1.25 particles per second. That's what we're looking for, that rate. Particles, 1.25 times 10 to the 8th and we're going to find that that's the particles, and the seconds would be 6.25 times 10 to the negative 4. So photons per seconds is the rate. Photons per second. So you can kind of see how this lines up. This has got a left side, and then you've got yourself a right side. Okay, so you got the same base. If you were to break this up, you can put a little line right through here if you wanted to. You can kind of see that this is the left side, and then this is the right side. Let's see if I can undo that. There we go. Okay, so 1.25 divided by 6.25 is actually 0.2. 0.2. This is 10 to the 8th over 10 to the negative 4 is 10 to the 12th. Okay, 8 minus negative 4 is 10 to the 12th. Okay. Now we need to put this into scientific notation. So what we did here in this case is we took 0.2 and we're going to move the decimal over to just 2 and change that to 10 to the 10 to 11th. Okay. So if you remember, we did this scientific notation before the break here. We had moved this decimal, this place over 1. So it's like 2.0 times 10 to the negative 1. Okay. And then that's times 10 to the 12th. And same base, you add the 2 together, you get 11. So the jellyfish emits 2 times 10 to the 11th photons per second. All right, couple on your owns and we're done for the day. Number 11, in example 3, which expression represents the area of a base of the cylinder? Okay, so we're looking for, we're going back to example 3, we're looking for the area of the base. Okay, so that's going to be the area of a circle is equal to pi times r squared. Okay, so in example 3, back here, the radius was h over 2. Okay, so if we plug in your radius as h over 2, and if you square that now, okay, you can see that you have pi times h squared over 2 squared, which is 4. So pi times h squared over 4. And if you look back on that example, pi times h squared over 4 was answer B. And the last on your own, number 12 for today, it takes the sun about 2.3 times 10 to the 8th years to orbit the center of the Milky Way. It takes Pluto about 2.5 times 10 to the 2nd years to orbit the sun. How many times does Pluto orbit the sun while the sun completes one orbit around the Milky Way? Write your answer in scientific notation. So we're going to end up taking 2.3 times 10 to the 8th years. It takes the sun about that long to orbit the center of the Milky Way. It takes Pluto about 2.5 times 10 to the 2nd years to orbit the sun. And as you look at that example here, figuring that one out, it's 9.2 times 10 to the 5, getting close to the end of my time. 9.2 times 10 to the 5 times. Okay, that concludes our lesson, folks. Any questions on that? Feel free to send me a note. And hopefully this was helpful on a review of your properties of exponents. And we'll see you back here. So look into your teams to see what the worksheet is. It would be really beneficial if you would upload the worksheet to Teams under the assignment, so it's easy for me to grade. But I understand there's situations, limits for some of you right now with what you have to work with. So snapshot, send it to me however you can. But if you can upload it to Teams, that'd be even great. And we'll talk with you next time. Thanks again for listening.